Students, a very good morning. So students, today in this class we will go to just do some online experiment. So as all of you are sitting at home and COVID time is again started, so online experiment and its lab, their importance are going to increase in this term. So as in your term 2 examination, first we will go for this online labs exactly. After that, if school will reopen, then we will go for the offline, means real lab practicals also. So here what you have to do first, you have to browse O labs. Then after browsing O labs, you will just find out one of the page. So students, first you have to just browse O labs, and after browsing it you can just see this page will be open. So if this page in this one you can see now 5 subjects are available for online just platform, the like physics, chemistry, biology, maths, English. Here you can also log in yourself by just doing registration. Now after this one, what you have to do, even without registration you can perform experiments from here. So first, after browsing, just go for physics now. And in while just clicking on physics, you will see here different class and its experiments are given here. Like in class 12th you can see number of experiments we have in class 11th and so on. So as here we are going for class 12th, and also you can see the term 1 practicals like Ohm's law, potentiometer, meter bridge. These all experiments are included here, but today we will go for now here the first experiment, that is the concave lens experiment. So here we will find out the focal length of the concave lens by this experiment now. So you have to click on this one, concave lens and focal length. So just click on this icon that is just shown here on this icon. After clicking on the concave lens, focal length of. So students, after clicking on concave lens, and as we have to find out here the focal length of concave lens, so you will see some of the options are given. If you are using laptop, then all the options like this you can see: theory, procedure, animation, simulator, viva voice, source and feedback. These all options you can see on the top of your screen. But here if you are using mobiles, then in this kind of screen you can see. Now we have to click on the theory section first, and if you will click on theory, then first you can see now here the first thing that is given, that one is the objective of our experiment. So here objective of our experiment is to find the focal length of concave lens using convex lens by lens in contact method, lens out of contact method. So here in our experiment we will go only for lens in contact method. So first, as we are going to just proceed for the experiment, we need to know which kind of instruments we need here. So next factor that we are needed after objective of our experiment, the materials that we are needed. So here for that one you will go in the section of procedure. Then you can see now lens in contact method. For that one, what kind of materials are given. So here materials that are required here for that one, that is illuminated wire case, lens stand, screen, meter scale, a convex lens of short focal length and concave lens. So it means that here we are going to find out the focal length of concave lens using convex lens. As you know, concave lens diverges the light, that's why we need a lens that can focus light. So that is done by the convex lens. So that's why we are using here convex lens to find out the focal length of the concave lens. After this, the next factor that we are needed to know, that is the theory of our experiment. So for theory of our experiment, again you have to go in theory section, from where you can see the theory of this experiment is given. First of all, the theory for concave lens is given, and after just giving the information about the image formation by concave lens, here lens in contact method, it is given now. So as here we have also studied in our classroom, that is when two lenses are in contact, then what will be the formula to find out their combined focal length. So here as when a concave lens that has focal length, suppose f2, that is placed coaxially in contact with the convex lens of focal length f1, and capital F is the focal length of the combination. So we can use simply this formula to find out the focal length here. And as we have to find out the focal length of concave lens, so we will use this one. So here what we can find out, we can easily find out the focal length of combination, because our lenses are in contact here. So we will perform experiment to find out capital F. Already here f1 that is given here, means the focal length of convex lens, that is known. Now we have to find out only f2. This is our you can say the objective of our experiment. And now you can see the image formation by for this combination by this diagram, where we can see a concave lens and convex lens that are kept in contact. Object is placed here, and when light rays are just falling on this one, then our image is formed here. So let's now, after this one, let's go for the here lens out of contact, as we are not going to use this one things. So let's go for our next section, that is first what kind of observations we are needed here. So for that one, again students, you have to go in procedure section. So in procedure section here, first real lab procedure is given for our experiment. So this one you will see when you will come in just real lab. So here first also along with real lab, always the online lab procedure is also given. I think here both of the places, here you can see this is simulator procedure is given as performed through the online labs. So you can here follow these instructions for lens in contact method, that you can perform experiment by yourself. But here I will just tell you these all procedures by myself also here. Now this one observation table, that is for lens in contact method, that you have to just draw. So I just recommend you to draw or to just these observation, just put this observation table with you. Then with experiment that you are going to perform, you can fill this observation table, and then you can easily calculate. So just to first make this observation table. Now after having this observation table, what is our next step? We will go for from here, that is on animation section. Also you can go for here. This animation section will help you to understand how to perform the experiment. So again I will just play this one for a short time. So if you will click on this one, the animated videos you can now see. So I just recommend you to see it for some time now.
Concave lens, focal length. Aim: to find the focal length of a concave lens using a convex lens by A. Lens in contact method, B. Lens out of contact method. Lens in contact method.
So here
to do the experiment, we require the following materials:
so as materials you will have
screen,
seen also,
illuminated wire gauze, meter scale, stand, short focus convex lens of focal length 10 centimeters, and the given concave lens. Place the combination of convex lens and concave lens fixed to the stand in front of the illuminated wire gauze in such a way that the convex lens is facing the wire gauze. The screen is placed on the other side of the lenses so that the wire gauze, lenses and screen are in a straight line. Place the combination of lenses at a distance of 20 centimeters away from the wire gauze, taken as U. Adjust the position of the screen to get a clear image of the wire gauze on the screen. Measure the distance between the combination of lenses and the screen.
So students, now here, this is our aim of this experiment. We have to put the screen, or here what you have to do, first you have to fix your source, then you have to fix object, that is at a source is just like the object here. On that one a cross that is made by the wire, and that is our object. We have to keep object distance from the lens as the fixed distance, means particular, suppose 15 centimeter, 20 centimeter you are choosing, then you don't have to move lens. Now you will move only this screen to find out the clear image of that one, and you can see now on the screen here a very clear image of plus sign is formed. So this is our now aim of this experiment. Now I think this one is clear from here. So let's go for our experiment now. For that one, for the next section, that is after animation simulator, this is our lab. Now we will go for this one. So you have to click on the simulator and then the lab will open in front of you. So just wait for a second here. So students, this is now our online lab. After clicking on simulator, that will open here. So in this one, again you can see here first, this is our screen on which we will see the image of the object that is kept here, and this is our lenses, two or lenses in which one is convex and one is concave lens. Here focal length of convex lens is fixed, that is we have taken the convex lens of 10 centimeter. You can also change this convex lens. You can also just change this convex lens from here, and you can see whenever you will change this convex lens, then these are all exactly the focal length of the same, that is of 10 centimeters. So any one of the lens you can choose from here. So suppose I have chosen lens 1 here. Now select the method is given here, lens out of contact and lens in contact method. So lens in contact method, we will go for this one here. Now again what you have to do, you have to fix this distance here. You can see this is the distance between lens and object. This is obviously object distance. So this object distance you will keep fix on some point. So suppose I'm just keeping this one here on 20 centimeter. So I have chosen the object distance as 20 centimeter. You can choose by yourself. Now for this 20 centimeter, we have to fix. First we have to just turn on this light, and then if you will turn on, you are seeing that on the screen none of the image we are getting of cross sign. So to get the clear image of the object, we will move this screen towards the lens now. So to move it, we will just use this one here. We will just move our screen now, and we have to find out by moving it the location where a clear image of the object that can be seen now. And you can see now along with this one the distance that is showing here already. So let's just find out the image location first. Here you can see the formation of image on this screen here, the plus sign that we can see, that is for the wire gauge. And now what we have done, as again if I will repeat it, that is first we have to select the method to produce the image or to find out the focal length of concave lens. So for that one we have kept lens in contact. Then we have chosen the concave lens. For that one we have chosen lens 1. If you will choose different kinds of concave lens, then focal length of the concave lens will be different. You can choose by yourself. Now the distance between lens and object, in this case we have kept it 15 centimeter. And for this 15 centimeter, then what you have to do, you have to just turn on the light, and then you should find out the location of the image in this case, and image will be formed whenever this plus sign that you will see for the wire gauge on this screen. So this is our whole of the work that we have to do in this experiment. Now we have to note this distance between the distance at which we have just kept our screen now. So on this optical bench, you can see this is mentioned already, 98.3 is the answer for this one. So in our chart we had to put the value of u and value of v, that we will just put here. Now we can calculate easily by the help of u and v, and by using lens formula the value of f, that is for the combination. Now this is our first experiment. Again what you have to do, you have to increase this distance that is the distance between lens and object. So increase this distance. Again, just put the screen in such a way you can see this plus mark on the screen. So this is our whole work. Only we have to find out for different object distance the image distances we need to find here. So let's do the experiment again for the here. So suppose here 20 at 20 centimeter we have kept our object now, and for that one again we have to change the location of here this screen to see the image of this on the screen. So I think you all have found out the image location for this object distance, that is for 20 centimeter, and you have got the wire gauge location, that is the plus sign on the screen now. And here I will recommend you to use laptop in place of mobile phone, because you cannot scroll the distance between lens and screen from here, and that's why you will face some problem. So here after this one let's go again in the section of procedure to see our chart that we have used here as the observation table. Now you can see in our observation table here we have object distance, image distance. So number of readings you have got for object and image distances, then you have to use this formula to calculate the focal length of combined lens, that is the focal length of combined convex and concave lens. After finding out f, we can use the lens combination formula here, and that lens combination formula will help us to calculate the focal length of concave lens by using this formula, that is f2 is equal to f1 upon f1 minus f centimeter. So this is our way to calculate now, and here after this one you have to put the result of this experiment here. Also here one of the another method is given, that is lens out of contact method, where we will put our lenses out of contact, that is there will be some separation between the lenses. And as in theory also we have studied about the when two of the lenses are at some separation, that is if they are separated by d distance, then what will be the formula for their combination. So the formula that time is given by as 1 by f is equal to 1 upon f1 plus 1 by f2 minus of d by f1 f2 if d is separation between them. Now in this case we will use this formula if we know what is the separation between lenses here, and also again using the same method we will find out this capital F, that is focal length of combined lens, and then f1 is already given, that is focal length for convex lens. We have to find out only the f2 here. And now for this case again materials required, that is given here, like the illuminated wire gauge, that again wire gauge is given, that's image you will see on the screen. For that one we need to stand, screen, meter scale, a convex lens of short focal length and concave lens. Now this is our real lab procedure that we will use when we will do the experiment in our laboratory. Now after this one you can see this is the image formation when we are keeping the convex lens and concave lens at some distance. Now for this one observation table is also given, again observation table is just like same. So here the distance between concave lens and here first image it is given, and then second image. So first image that will be u. For this obviously here you can see the image that is formed by convex lens, that will be the object distance for concave lens, and the final image that is made by concave lens, that will be the image distance. So we have to find out here the first image distance from the concave lens and second image distance. So the first image distance will be u, second image distance will be v here. Then we will use the formula to find out the focal length of concave lens directly here. And now after this one calculations method, result how to write, that is already given here. Now next one here one more thing, simulator procedure that is given now. So simulator procedure, that is for the lens in contact we have used already. Now for lens out of contact, if one time we will see, first you have to turn on the wire gauge, then click on the light on button. Then next to adjust this distance between convex lens and the screen using the slider to get a clear image of the wire gauge on the screen. So when a clear image is formed, click on the insert concave lens button to insert the concave lens in between lens and convex lens. Then again you have to set the position of concave lens from the screen using the slider. It is taken as U. So adjust this distance between concave lens and screen so that you can get the clear image of wire gauge on the screen. That will be V. Now we can use the formula. So let's again go for the simulator lab here to find out whether we can perform this experiment by this one or not. So again now we are in our lab. So for this one, first what you have to do, you have to go for lens out of contact method. So we have selected lens out of contact. Again suppose concave lens 1 we are just selecting. For this one we have to just put light on, and after putting light on you have to find out the clear image of again the object here. So that work you can do now. After doing that work, what we have to do, we have to insert concave lens here, and if we will insert now the concave lens, then again we have to find out here the location for the image here. So students, I think the lens in contact method, that is completely clear to you. So here lens out of contact method, for that one as just now I have told you, first what you have to do, you have to just set your convex lens in the focal just order, means the convex lens will be set up in that manner in which you can see on the screen the wire gauge, that's image. So you are seeing that now. Now after that here you can see one of the option, that is insert concave lens, that is showing here, and I don't know why it is showing just disable in my device. So this may be due to network. So if it is showing in your device, then that time you have to insert concave lens. Then for that one again you have to get the same position, means the clear image of the wire gauge on the screen as you are seeing now. So this is our objective here for this whole of the experiment. Now after doing this number of times, you have to just change the position of object, that is this time that is 15 centimeter as you can see, and now this 15 centimeter you will change to 20, 25, 30 and so on. For that all you have to find out the image location. So this is our objective of this whole of the experiment now. After this one students, you have to just go for the calculation for lens out of contact method if you have got the readings for U and B there. So for that one here what you have to do, the first image distance that we had found out for the convex lens, that is object distance for the concave lens, that is U, and the second image when after putting concave lens that we have found out, that is the second image. Now after just putting the data in first image and second image, you have to use this formula to calculate directly the focal length of concave lens. So this is our now observation and the calculation that we have done by the formula here. And after this, when we will just take mean of all these readings, then we can find out the focal length of concave lens. So these are now two methods through which we can find out easily. We can find out easily here the focal length of concave lens by two methods, like by contact in method and by lens out of contact method. So you can just any of the method here for that one. So this is our whole of the objective here, and now after this one you have to write down the result of this one. So result you can write down again. Students, after conduction of this experiment you have to go in procedure, and then you can write after calculation here by using this formula. You can just use this formula for lens in contact method, and for lens out of contact method, the formula that we have to use here, that is the direct thin lens formula. You can use this one, that is F is equal to UV upon U minus V centimeter. So after that one you can write down the result, that the way to write down the result, it is given here. So this way you have to follow. So by any one of the method you can find out the focal length of the concave lens. So there are basically two methods, that is lens in contact method and lens out of contact method. We can use any one of them to conduct our experiment and to find out the focal length of concave lens. So I think all of the experiment whatever we have conducted today, that is all clear to you. And if lens out of contact method is not working properly, then use lens in contact method to find out the focal length of the concave lens by using combination formula. So students, let's end our class here with this one. Thank you, students.